Homo sapiens is the sole survivor of a group of hominins that lived on our planet during the last ice age, including what is generally considered a separate species, Homo neanderthalensis, though it can be argued that they should be a subspecies, Homo sapiens neanderthalensis. That subspecies name was coined way back in the 1960s, but was then dismissed by a new theory that claimed Homo sapiens to be a new, pure population of humans that evolved in a small Garden of Eden. Although the Neander Valley man is now the term we use for them, it could have also been Homo calpicus, which refers to a deformed skull, or calvaria, found in Gibraltar. Another term was Homo mustierensis, after the Moustier site in France. Some have suggested that humans interbred with Neanderthals to the point where there weren't enough pure Neanderthals left. It is well known that interspecies breeding can create infertile males, such as the case of horse-donkey hybrids known as mules. So did inbreeding create hybrid human mules? Indeed, it has been argued for at least a century that there was interbreeding between modern humans and Neanderthals, a claim that was dismissed by the dogmatic out-of-Africa theory in the 1980s. Though the out-of-Africa theory originally fiercely defended the idea that modern humans were a pure human that descended from a small population and then spread out, replacing all other human species, we now know that the real story is much more complex. In less than 1,000 years after their demographic peak 42,000 years ago, there was a rapid decline and the Neanderthal disappeared from the scene. In simple terms, this extinction looks like a blitzkrieg, in which Neanderthals were wiped out by colonizing modern humans with advanced long-range projectiles. First off, this disappearance, which culminated in their species extinction 2,000 years later, is ludicrously rapid. Secondly, this evidence suggests that, from the very height of their population, Neanderthals in Western Europe went extinct within just a couple of thousand years. Their sudden disappearance is shocking and unprecedented in human history. The causes of the disappearance of the Neanderthals, Europe's only human population prior to the arrival of Homo sapiens, have been debated by scientists for decades. Various hypotheses have been advanced to explain this extinction, including Neanderthal, cognitive, adaptive, and cultural inferiority. We now know that Neanderthals descended from the European branch of hominins, and that their differentiation in Europe was the result of a long evolutionary process. Nonetheless, Neanderthals, the only humans on European territory at the time, vanished in an instant when Homo sapiens arrived. Indeed, the causes of Neanderthal extinction sparked a heated scientific debate, with a number of hypotheses proposed to explain their extinction. Because the Neanderthals vanished at the same time that Homo sapiens colonized Europe, their extinction has been linked to the spread of Homo sapiens. In spite of the fact that researchers agree on the small size of the Neanderthal population, its precise and accurate estimation remains difficult. Attempts on the basis of demographic modeling applied to Neanderthals proposed for the entire Neanderthal population a maximum number of 70,000 individuals. Researchers explored qualitatively the possible cause of the Neanderthal population demise in terms of demographic changes, involving above all a reduction in its size. In the absence of paleodemographic data regarding Neanderthal populations, scientists used demographic models to search for what values of demographic parameters could have maintained a demographically stable population. In a second step, they altered these values to quantify the necessary change in demographic parameters, leading Neanderthals to extinction over a period of 10,000, 6,000 and 4,000 years, which is within a time frame compatible with the known history of modern humans in Europe. Then, scientists also examined the effects of reduced survival rates of different age classes on extinction probability and time to demise. They started by projecting the effect of a reduction in survival of the youngest children, and finally studied two catastrophic scenarios, the situation of an epidemic and a war scenario, both of which would affect survival rates of adult individuals. Scientists used demographic modeling and simulations to identify the set of plausible demographic parameters of the Neanderthal population compatible with the observed dynamics, and to explore the circumstances under which they might have led to the disappearance of Neanderthals. Moreover, a slight 4% but continuous decrease in the fertility rate of younger Neanderthal females could have had a significant impact on these dynamics and could have precipitated their demise. The results open the way to non-catastrophic events as plausible explanations for Neanderthal extinction. Nevertheless, although the study is focused on females, disappearance could be linked to men's fertility. A significant loss of men due to intergroup conflict or hunting accidents would have been of great importance for their physical condition, and hence for female Neanderthal fertility. Neanderthal reproductive decline could be amplified by Homo sapiens. Neanderthals and Homo sapiens experienced some hybridization in Central Asia and in Western Siberia and on the European continent, as suggested by anthropological and genetic evidence. This hybridization, although important for sapiens, allowing the introgression of several useful genes, especially for pigmentation and metabolism, in cold climates, concerned, however, a very small number of individuals, possibly only 1,000 to 2,000 people. Indeed, the genetic comparison of the Y chromosome between modern humans and one Neanderthal suggests that some mutations present in Neanderthals could have caused infertility problems in male hybrids. Such mules with less fertility may have contributed to a decrease in the fertility rate in the Neanderthal population, whereas in the sapiens population, their high numbers would have been able to bounce back after a few hundred years. Therefore, if male hybrids between Neanderthals and modern humans were infertile, it would indeed mean that only hybrid females passed on Neanderthal genes to subsequent generations. This is a key implication of the male infertility hypothesis tied to the absence of Neanderthal Y chromosome DNA in modern humans. The Y chromosome is inherited paternally and doesn't recombine except in small pseudo-autosomal regions. Neanderthal Y DNA is absent in modern humans due to male hybrid infertility or strong selection against it. The Neanderthal Y chromosome differs from modern human Y chromosomes at key locations. Studies suggest a Neanderthal Y chromosome had mutations incompatible with modern human autosomal genes, causing sterility or immune rejection in male hybrids. Fertile female hybrids could pass on autosomal Neanderthal DNA, but male hybrids couldn't reproduce, purging Neanderthal Y chromosome from the gene pool. Neanderthal modern human hybrids likely produced viable females but infertile males. This mirrors mule sterility. First, let's imagine a world where all male hybrids, offspring of Neanderthal males and modern human females, are infertile, like mules, hybrids of horses and donkeys. This would mean any male child born from a Neanderthal modern human pairing couldn't have offspring of their own, while female hybrids might remain fertile. Socially, this could lead to tension or avoidance between modern humans and Neanderthals. Modern human tribes might see Neanderthals as a threat to their future, banning interbreeding or isolating hybrid males who couldn't contribute to the next generation. This could create cultural divides, with stories or taboos against mixing, shaping group identity and survival strategies in Ice Age Europe. If only male hybrids were infertile, female hybrids could still have children with either modern humans or Neanderthals, passing on Neanderthal DNA. This would shift social dynamics, making female hybrids valuable for reproduction, but male hybrids outcasts or burdens. Modern human groups might prioritize fertile males, their own or fertile hybrids for mating, while female hybrids could bridge populations, increasing genetic diversity but complicating alliances. Families with infertile male hybrids might face stigma or social strain, as these males couldn't produce heirs or help grow the tribe. This could lead to matrilineal societies, where women's fertility became central, or to abandoning hybrid males, impacting community cohesion and care systems. Infertile male hybrids might still contribute to culture, teaching tools, fire-making or hunting skills learned from Neanderthals, without passing on genes. However, the lack of genetic legacy could reduce long-term Neanderthal influence, limiting traits like height or immunity in modern humans. Socially, modern humans might adopt Neanderthal technologies but reject interbreeding, slowing genetic mixing and preserving cultural boundaries. If Neanderthal males fathering hybrids resulted in infertile sons, Neanderthal populations could face extinction faster. Modern human females mating with Neanderthals might produce fertile daughters, but infertile sons, draining Neanderthal reproductive potential. This could explain why Neanderthals disappeared by 40,000 years ago, as their genes flowed into modern humans, but their own numbers dwindled. Over time, modern human groups might develop strict mating rules, favoring in-group reproduction to avoid infertility. This could lead to more isolated, homogeneous societies, but also slower genetic adaptation to Ice Age challenges. Alternatively, if female hybrids were fertile, Neanderthal DNA could persist through them, but male infertility would delay population growth, impacting survival in harsh climates. Infertile males could still participate in relationships, forming bonds with modern human or Neanderthal females, even if they couldn't father children. This might lead to them being valued for companionship, protection, or cultural exchange, for example, teaching tools and hunting skills, rather than reproduction. Indeed, their infertility could create tension. Modern human tribes might see them as less valuable or exclude them from mating, while Neanderthal groups might view them as inferior. Tribes might create myths or taboos about hybrid males, labeling them as barren warriors, or using them in non-reproductive roles, preserving their social value despite infertility. In many hunter-gatherer tribes, the chief fathers children with many women, so this might not be such a major problem in tribes with more open views on relationships. This could maintain genetic exchange through fertile female hybrids, but it might confuse lineage tracking or inheritance, leading to new social rules about paternity and kinship. Over time, tribes might avoid Neanderthal mating to ensure fertile offspring. Neanderthals, already declining by 41,000 years ago, might face reduced mating opportunities if modern humans avoided their males due to infertility. However, if infertile hybrid males still married Neanderthal females, it could maintain social ties but not genetic legacy, hastening Neanderthal extinction as their numbers dropped without new offspring. In a study titled A Critical Review of the Middle Paleolithic in Western Central Europe from its beginnings to its rapid decline, found that Neanderthals completely disappeared just 3,000 years after their population peaked in Western Central Europe, according to the study. With Homo sapiens advancing from the south, Neanderthals appear to have taken refuge in northern Germany on the Elbe and Weser River on the North German plains, before they rapidly went extinct. Classic Neanderthals lived in the Middle Paleolithic, or Middle Old Stone Age. This period encompasses the time from roughly 200,000 to 40,000 years ago. More than 50% of the known Neanderthal settlement sites in Germany can be dated to the Middle Paleolithic. More precisely, they date back 60,000 to 43,000 years before our times. So, the Neanderthal population peak seems to lie in this period. The number of sites, their analysis, and the analysis of the artifacts found at these settlements indicate that the Neanderthal population in Germany was subject to extreme demographic fluctuations. During the Middle Paleolithic, there appear to have been several migrations, population increase and decline, extinction in certain areas, and then a return of settlers to these areas. While for the time period between 110,000 to 70,000 years ago, there are only 4 known settlement sites. In stark contrast, in the following period from 70,000 to 43,000 years ago, there are 94 sites. Tellingly, they are mostly clustered in one region in the far north, but this type of density is unknown in the prior Neanderthal record. One possibility is that Neanderthals were being forced out of southern Europe, and the survivors took refuge in northern Germany during this period. In a third study titled, Was Demographic Weakness the Cause of Neanderthal Demise?, scientists investigated the disappearance of Neanderthals by examining the extent of demographic changes needed over a period of 10,000 years to lead to their extinction. In regard to such fossil populations, they inferred demographic parameters from present-day and past hunter-gatherer populations and from bioanthropological rules. According to the most commonly accepted hypothesis, the Neanderthals would have competed with Homo sapiens for food resources and the replacement of Neanderthals would have been favored by Homo sapiens' greater technical skills, their greater cognitive abilities, Neanderthals' narrower diet, and lower social capacities and network. The question of what killed off the Neanderthals is one of the greatest scientific mysteries of our time. Our evolutionary cousins vanished almost without a trace around 40,000 years ago, and no one can agree on what doomed them to the abyss of history. It's still unclear why the species went extinct. Perhaps it was because of the evolution of Homo sapiens. Is it a coincidence that humans arrived in Europe at the height of the Neanderthal reign and that our evolutionary cousins soon fell into a sudden terminal decline? Probably not, but this question will keep scientists busy for decades to come. The replacement theory emerged in a scientific and cultural context that often sought to elevate a single superior origin for modern humans, reflecting biases prevalent in 20th century anthropology. By emphasizing a single African origin followed by replacement of all other human groups, the theory implicitly framed Eurasian populations, like Neanderthals in Europe or Denisovans in Asia, as evolutionary dead ends, inferior to the successful Homo sapiens. This narrative aligns with colonial-era ideas of progress and superiority, where one group is seen as inherently better, destined to dominate and erase others. This narrative mirrors historical ideologies that prized purity and viewed hybridization as degenerative. By denying interbreeding, the model rejected the possibility that modern humans could be a product of diverse genetic contributions, instead framing Homo sapiens as a singular, untainted lineage. This prioritizes a monolithic origin over a more inclusive, hybridized one. The theory's inability to adapt to this evidence without significant modification highlights its limitations. Its initial rejection of interbreeding delayed a more accurate understanding of human evolution, perpetuating a simplistic and exclusionary view of human origins that ignored the diversity of our ancestry. Either way, Europe was ours 40,000 years ago, and the light of the Neanderthals was enigmatically extinguished. But were Neanderthals really a separate species driven to extinction, or just a unique population of Homo sapiens that was assimilated into the modern population? The classic biological definition of a species hinges on the ability of two groups to interbreed and produce fertile offspring. If they can, they're considered the same species. Yet the paper in question argues that Neanderthals and Cro-Magnons, Homo sapiens, are separate, citing differences in physical traits, behaviors, and evolutionary paths. But is this separation justified, or does it oversimplify a more complex, interconnected reality? One of the most compelling pieces of evidence that Neanderthals and Cro-Magnons belong to the same species is their ability to interbreed. Genetic studies have shown that when these two groups met around 50,000 years ago, they didn't just coexist, they mixed. Modern non-African humans carry about 2% Neanderthal DNA, a legacy of this intermingling. If two groups can produce viable, fertile offspring, as this genetic legacy suggests, doesn't that align them with the same species under the biological species concept? The paper argues that morphological differences, like Neanderthals' robust builds and distinct skull shapes, outweigh this genetic overlap. But is appearance alone enough to draw such a hard line? Neanderthals and Cro-Magnons shared a recent common ancestor, and their interbreeding produced children who, in turn, had their own offspring. This fertility across generations is a hallmark of a single species. So why does the paper insist on separation? It's complicated. Beyond genetics, Neanderthals and Cro-Magnons also shared cultural and technological practices, further blurring the lines between them. Archaeological evidence shows that both groups used similar tools, buried their dead, and even created art. Cro-Magnons are famous for their cave paintings, but Neanderthals also left behind symbolic objects, like eagle talons arranged as jewelry. If they were engaging in comparable behaviors, doesn't that suggest a shared cognitive and social framework? The separate species concept counters that these similarities are superficial, but isn't the ability to communicate, cooperate, and innovate a deeper indicator of species unity? Think about it. If two groups can understand and mimic each other's behaviors, aren't they part of the same cultural and biological continuum? The paper's emphasis on speciation complexity overlooks this overlap, focusing instead on differences in brain size or cranial features. But does a slightly different skull shape really justify calling them separate species, especially when their lives were so intertwined? This raises a critical question: are we letting fossil morphology dictate our conclusions more than it should? Another article from the British Natural History Museum by Chris Stringer, titled "Are Neanderthals the Same Species as Us?" asks, but what about the archaeological evidence that is also commonly cited in favour of uniting the Neanderthals with us as Homo sapiens? That they had cultural behaviours such as burying their dead and painting designs on the walls of caves. Well, interesting as that is, it should be excluded from the biological classification of species, since behaviours are potentially more plastic, evolve more quickly and spread more easily within and between species than traits based on anatomy and DNA. In addition, demonstrating that a past human species had a particular behaviour is sometimes difficult to establish from the archaeological record, the museum concludes. It's worth taking a deep dive to address this point directly, as it hinges on dismissing behavioural evidence like burial practices and cave art as irrelevant and unreliable for classifying Neanderthals and Cro-Magnons. While it is easy to understand the concern about the plasticity and difficulty of interpreting behaviours, suggesting that it's unreasonable to consider them at all is itself a stretch. Behaviours, far from being mere noise, can offer critical insights into the cognitive and social capacities of these groups, which are deeply tied to their biological identity. Many researchers refute this dismissal and argue that ignoring behavioural evidence is not only short-sighted, but undermines a holistic understanding of species classification. The Natural History Museum claims that behaviours like burying the dead and painting on cave walls are irrelevant to species classification, because they're potentially more plastic, evolve more quickly, and spread more easily than anatomical or DNA traits, and that they're hard to establish from the archaeological record. But isn't it absurd to throw out such rich evidence simply because it's complex? Behaviours aren't just side notes. They're windows into the minds, cultures, and evolutionary pressures that shaped Neanderthals and Cro-Magnons. To dismiss them as unreliable or secondary is to ignore half the story of what makes a species a species. First, let's tackle the plasticity argument. Sure, behaviours can change fast and spread through cultural exchange, but that's precisely why they matter. If Neanderthals and Cro-Magnons both engaged in symbolic behaviours like burial and art, doesn't that suggest a shared cognitive capacity that's as fundamental to their identity as their bone structure? The ability to create meaning, mourn the dead, or express creativity isn't some superficial add-on. It's a hallmark of advanced hominid evolution, likely rooted in their shared biology. To say it's irrelevant because it's plastic is like saying language doesn't matter in humans because accents can change. Ridiculous, right? Now, about the difficulty of establishing these behaviours from the archaeological record. Yes, it's tricky. Cave paintings can degrade and burial sites can be misinterpreted, but the same can be said for fossils and DNA. Fossils are rare, often fragmented, and subject to speculation in how we interpret them. DNA can be contaminated or incomplete, yet we don't dismiss those entirely. Why should behaviour be held to a higher standard of proof? The evidence we do have, Neanderthal burials with grave goods, pigments found at their sites, and Neanderthal cave art overlapping with Cro-Magnon cave paintings in time and space, shows striking parallels. To wave that off as too hard to pin down is to miss the forest for the trees. And here's the kicker. Behaviours aren't isolated from anatomy and DNA. They're products of the brain, which is itself a biological trait. If Neanderthals had the neural wiring to bury their dead or make art, that capacity is as much a part of their species definition as their skull shape. The Natural History Museum leans on anatomical and genetic data, but it's laughable to think we can fully understand speciation without considering how these populations thought and acted. Species aren't just bodies, they're living, breathing entities with minds, and behaviours give us a glimpse into those minds. The suggestion that behaviour is irrelevant doesn't hold up under scrutiny. It's not ridiculous to look at all available evidence, it's ridiculous to arbitrarily exclude a whole category of data because it's messy. Science thrives on complexity, not simplification. The archaeological record may be imperfect, but it's our best tool for understanding the past. To say we should ignore behaviors because they're hard to interpret is like saying we should ignore the weather forecast because some measurements are uncertain. It's a cop-out, not a reasoned stance. Moreover, the focus on anatomical and genetic separation might itself be flawed if it overlooks how behaviors reflect underlying biological similarities. If Neanderthals and Cro-Magnons shared the brain power for art and ritual, their biology was clearly compatible enough to warrant classification as the same species. In short, dismissing behavioral evidence as irrelevant and unreliable is not only short-sighted, it's downright absurd. Behaviors like burial and art aren't distractions. They're essential pieces of the puzzle that show Neanderthals and Cro-Magnons were more alike than different, likely part of the same species, Homo sapiens. The Natural History Museum might prioritize anatomy and DNA, but to ignore how these groups lived, thought, and interacted is to miss the full scope of their humanity. In fact, the 2% Neanderthal DNA in modern humans isn't just about genes. It's about the legacy of their shared ways of life, too. So, the next time someone claims behaviors don't matter in species classification, ask yourself, if we can't learn from how our ancestors acted, what are we even studying? The richness of their lives, their creativity, their rituals, their connections, deserves a place at the table, not a dismissive shrug. It's not ridiculous to include behavior. It's ridiculous to pretend we can understand species without it. Genetically, Neanderthals and Cro-Magnons were remarkably similar. Their genomes differ by less than 0.1%, which is a minuscule gap compared to the differences between, say, humans and chimpanzees. This closeness suggests they were not only capable of interbreeding, but also part of a continuous gene pool. The Natural History Museum points to specific genetic markers or fossil evidence to argue for separation, but these markers could just as easily be regional variations, like dialects in a language. If we accept that small genetic differences don't create new species, why should we treat Neanderthals and Cro-Magnons as exceptions? Moreover, the presence of Neanderthal DNA in modern humans isn't just a historical footnote. It's a living testament to their shared species status. Every time someone with European or Asian ancestry inherits a snippet of Neanderthal DNA, they're carrying forward a legacy of interspecies mingling. Doesn't this continuity undermine the idea of rigid species boundaries? The paper's focus on speciation complexity might miss this forest for the trees, prioritizing theoretical models over empirical data.